welcome to the Deep Dive. Today, we're going deep into this idea of knowledge distillation for large language models.
LLMs.
Yeah, LLMs, as you developers out there probably call them.
Yeah, definitely.
We've got some fascinating research here, and it explores this really cool concept of how we can transfer the capabilities from these massive AI models to smaller, more manageable ones.
Right. And that's really the key here, right? Because as you know, we've got these huge models and they're powerful,
Right.
but we need to be able to kind of distill that down so we can actually use them.
Yeah, it's got to be practical for all of us,
Exactly.
especially developers.
Exactly.
So it's like taking the brain of a supercomputer
Yeah.
and then like
Putting it in your pocket.
putting it in your pocket. Like instead of shrinking the hardware, we're shrinking.
Yeah, we're transferring knowledge and skills.
Okay.
Like imagine being able to, integrate these powerful AI capabilities into your app without needing a server farm.
Oh, so I don't need to carry around a giant mainframe.
Yeah.
Just to run like a simple chatbot or something.
Exactly. Yeah. And it opens up a whole world of possibilities for developers.
Yeah, I see that.
Yeah.
So the research also talks about this distinction between proprietary LLMs and open source LLMs.
Right.
Why is that so important in understanding knowledge distillation?
Well, you got to think of the proprietary models like your GPT-4s and your Geminis.
Okay.
They're powerful.
Yeah.
They're incredibly capable, but, they have limitations, especially for developers.
Okay.
They're expensive.
Yeah, they are.
They raise data privacy concerns, and they offer limited customization.
So not very practical.
Not super practical, no.
For real-world development.
Right. So then on the other hand, we have open source models. These are free, adaptable, give you full control of your data.
I like that. Yeah. There's got to be...
They haven't quite caught up to the performance of the proprietary ones.
Okay, so there's a trade-off there.
Exactly. It's a trade-off.
Okay.
So knowledge distillation is like the bridge
I like
between the two.
So we're taking the best of both worlds.
Exactly. We can take the knowledge from those proprietary models and transfer it
to
the open source models, and boom.
Giving them a boost.
Give them a boost, exactly.
Okay, so instead of starting from scratch with an open source model, we can give it like a head start.
Exactly.
By like injecting it with knowledge from a more advanced model.
Yeah, it's like giving it a crash course.
Oh, I like that.
From the best AI teachers.
Yeah.
Yeah. And it's not just about boosting performance either.
Oh, really?
Yeah, there are other uses.
Okay, like what?
Well, you can use it for traditional compression, creating smaller, more efficient models that can run on devices with limited resources.
Oh, so like on my phone.
Your phone, your smartwatch.
So I could have like powerful AI assistant on my wrist.
On your wrist.
That's cool.
Yeah, and there's another emerging trend. Self-improvement. Where open source models can generate data and then use that data to refine their abilities.
So they're like AI apprentices.
Yeah, exactly.
That are learning to become their own masters.
Exactly.
That's incredible. But how did we get to this point?
Yeah.
Like from basic model compression to this idea of like multifaceted knowledge transfer.
It's an evolution.
Okay.
Early knowledge distillation was all about making models smaller and faster.
Right.
But LLMs changed everything.
Okay.
Because they're so packed with information, the focus shifted to extracting and transferring that knowledge strategically.
So it's like going from copying a textbook to actually like understanding the core concepts and applying them in different ways.
That's a great way to put it. It's not just about replicating the teacher model's output anymore. It's about eliciting and transferring specific knowledge and skills.
So how do we do that?
Yeah.
How do we get that valuable knowledge out?
Well, data augmentation is a key technique.
Okay.
Think of it as crafting a specialized training regimen for the student model using carefully selected and tailored data.
So we're not just throwing any information at it.
No.
It's like very curated.
Curated, refined, targeted to specific skills. We want the model to learn.
So it's like a personal trainer.
Exactly.
For AI, giving it the right exercises and feedback.
Exactly.
To reach its full potential.
Yeah, and there's a bunch of different methods for eliciting this knowledge from these massive LLMs.
So what's in this knowledge extracting toolbox?
Well, one common method is labeling, where we use the teacher model to annotate data for different tasks. Categorizing text or evaluating text quality.
Oh, so it's like having a team of experts.
Exactly.
Relabel all the training data.
Saves a ton of time.
Going on.
Another powerful tool is expansion.
Yeah.
We use the teacher model's generative abilities to create additional data samples based on a small seed set.
Oh, so we can take a small piece of knowledge and use the LLM to expand it.
Exactly.
To create this big data set.
Exactly. It's like bootstrapping knowledge.
Yeah, I like that.
Yeah. And then there's curation.
Okay.
Where we carefully select and filter data.
Okay.
Creating a high-quality data set.
So it's all about quality over quantity.
Absolutely. Making sure the student is learning from the best possible data.
Right.
And we can also use feedback mechanisms. Where the teacher model provides feedback on the student model's performance.
Like having a personal tutor.
Exactly, like a tutor.
For AI.
Yeah.
Wow.
And on top of all of that, we have self-knowledge generation, where student models can learn to create their own knowledge.
So they're evolving into independent learners.
It really is remarkable.
That is remarkable.
Yeah, these methods are just the first step in the process, though.
Okay, so what happens next?
Well, that's where we get into the distillation algorithms.
Okay.
And that's where things get even more technical.
Right, let's do it.
All right.
Let's get technical after the break.
Sounds good.
Okay, so we're back and we're ready to get into these distillation algorithms.
All right, let's do it.
You mentioned that there's a bunch of different approaches.
Yeah, there are.
What are some of the most common ones?
So one of the most widely used is called supervised fine-tuning, or SFT for short.
Okay.
And basically, we're just giving the student model a set of practice problems and showing it how the teacher model would solve them.
Oh, so it's learning by example.
Exactly. It's a classic teaching method.
Yeah.
But it's remarkably effective for transferring knowledge. And then another family of techniques focuses on this idea of divergence and similarity.
Okay.
Essentially, we're trying to either minimize the difference between how the teacher and student models process information or maximize the similarities in their internal representations.
So we're trying to get the student model to think like the teacher model.
Exactly, think like the teacher.
Okay.
So one way to do this is by using a concept called KL divergence.
Okay.
It sounds complicated, but it's a way of measuring how different two probability distributions are.
Okay.
So in the context of knowledge distillation, we can use KL divergence to nudge the student model's probability distribution closer to the teacher's.
So it's kind of like guiding the student model to make predictions that are more in line with the teacher's prediction.
Exactly. That's a great way to put it.
Okay.
And there are two main types of KL divergence.
Okay.
Forward KL divergence and reverse KL divergence.
All right, what's the difference?
Think of it like this.
Okay.
Forward KL divergence is like casting a wide net. We want the student model to cover all the possible outputs the teacher might produce.
Okay.
Even the less likely ones.
Okay.
So it's good for situations where we want the student model to be comprehensive and consider a broad range of possibilities.
So it's more about breadth of knowledge.
Yes, breadth of knowledge.
Okay.
Now, reverse KL divergence is more focused.
Okay.
It prioritizes the most likely outputs of the teacher model. So this approach is better when we need the student model to be very precise and specialize in the teacher's core areas of expertise.
So it's like the difference between being a jack of all trades and a master of one.
Exactly. It's that trade-off.
Okay, so choosing which type of KL divergence to use really depends on like the specific task and what we want the model to do.
Exactly. It depends on the task and the desired behavior of the student model.
Got it. Okay, so what other algorithms are out there?
Well, another powerful technique is reinforcement learning, or RL.
Okay.
Remember that idea of training a dog with treats?
Yeah, positive reinforcement.
Exactly, positive reinforcement.
Okay.
Well, RL is similar.
Okay.
We train a separate reward model that learns to evaluate the student's performance based on feedback from the teacher model. Then we use RL algorithms to optimize the student model so that it gets the highest possible rewards.
So the student model's always striving to impress the teacher.
Yeah. Exactly. It wants those virtual gold stars.
That's fine.
And this approach is particularly effective for tasks where we want the student model to not just mimic the teacher's outputs, but also learn the underlying reasoning and decision-making process.
So it's like teaching the AI to think for itself.
Exactly. We're getting there.
Wow, that's pretty cool.
Yeah.
You mentioned ranking optimization earlier.
Right.
What is that all about?
Yeah. So ranking optimization is all about incorporating preferences from the teacher model into the student model. So we can actually directly influence the student model's outputs by highlighting which outputs the teacher prefers.
Oh, so it's like saying, hey, student model, pay attention to these kinds of results.
Exactly. Yeah.
The teacher likes these.
Yeah, like these are the good ones.
Okay.
Focus on these.
Gotcha.
It's a way of subtly shaping the student model's behavior
to
align more closely with the teacher model's expertise.
Got it. Okay, so we've covered a lot of different techniques and algorithms here.
I have.
But it all boils down to this idea of transferring knowledge from a teacher LLM to a student LLM.
Exactly.
Now, I'm curious about the types of skills we can actually distill using these methods.
Yeah, that's the real question, right?
What can these student models actually do that's relevant to us developers?
That's the key question. And the amazing thing is that knowledge distillation allows us to enhance very specific skills in these LLMs that are directly applicable to the challenges developers face every day.
All right, let's hear it. What superpowers are we talking about?
Okay, so one area where knowledge distillation really shines is context following. We can train models to understand and respond to instructions very effectively, carry on multi-turn dialogues, and even access external information to enhance their responses.
So they can follow our instructions, hold conversations, and even do research on the fly.
Exactly.
That sounds incredibly useful.
It is. It's useful for all sorts of applications.
And I can imagine.
Yeah. And we can also teach them to think more like humans.
Okay.
We can distill reasoning patterns from teacher LLMs, teach the student models how to approach problems and break down complex tasks.
So they can think critically and solve problems logically.
Exactly. That's what we're aiming for.
That's really cool.
Yeah. And then there's alignment.
Okay.
Making sure these AIs are aligned with human values and expectations.
Right. So it's not just about making them smart.
No.
It's about making them good.
Exactly. We want them to be good.
Yeah. That's really important.
Especially as AI becomes more integrated into our lives.
Absolutely.
And then there's the exciting world of agent-like behavior. Oh, okay.
We can train models to use tools, plan complex tasks, and even interact with the real world through APIs.
Wait, so AI using tools?
Yeah.
That sounds like a sci-fi movie.
It's becoming less fiction and more reality every day.
That's true.
Like imagine an AI that can automatically generate documentation for you.
Okay.
Debug your code, or even refactor your code base based on best practices.
Oh, okay, my mind is officially blown.
It's pretty amazing stuff.
It is. But can we get even more specific?
Sure.
How is knowledge distillation being used to enhance those core NLP tasks that are so crucial for software development?
Well, knowledge distillation can be used to create specialized models that excel at tasks like natural language understanding, natural language generation, information retrieval recommendation systems, text generation evaluation, and even code generation.
Wow. So we can use knowledge distillation to improve pretty much any NLP task.
It's a very versatile technique.
Okay.
And it's not just limited to text-based tasks either.
Oh, really? Yeah. We're seeing amazing progress in multi-modality.
Okay.
Where we're training models to understand and generate content across different modes of input.
So like text, image, audio, video?
Exactly, all of that.
So we're moving towards an AI that can perceive and interact with the world in a more human-like way.
That's the goal.
That's incredible. I can't wait to see what the future holds.
It's an exciting time to be working in this field, that's for sure.
It is. All right, so we've talked about the algorithms. We've talked about some of the capabilities now. Let's get into some real-world applications.
Let's do it.
Let's see how this is actually being used in different industries after the break.
Sounds good.
Okay, so we're back, and we've been talking about all these amazing things that we can do with knowledge distillation.
Yeah.
But now I want to hear about how it's being applied, like, in the real world.
Right. Let's get into the applications.
Yeah, in specific industries.
Exactly. And this is where it gets really interesting for developers.
Okay.
Because we can take these powerful general-purpose LLMs and fine-tune them to become experts in specific fields.
Okay.
Like law, healthcare, finance.
Oh, so it's like we're creating specialized AI assistants.
Yeah, exactly.
For different professions.
Precisely.
Okay, let's start with law.
Okay.
Legal language is super complex, right?
It is. It's filled with jargon and very subtle interpretations.
Yeah, and traditional AI models have really struggled with that.
They have, because it's not just about understanding the words. It's about understanding the context and the underlying legal principles.
Okay, so how does knowledge distillation help with that?
Well, we can train LLMs on these massive legal databases and fine-tune them with specific instructions and feedback to create AI that can actually understand legal documents, answer legal questions, and even assist with legal research.
So it's like having an AI paralegal.
Exactly.
That can just sift through mountains of legal documents.
Yeah, and it can save lawyers a ton of time.
Yeah, I bet. And this is actually happening, right?
It is. It's already happening.
Wow.
There are AI-powered legal research platforms out there that can analyze case law statutes regulations to provide insights and support legal decision-making.
That's incredible. What about healthcare?
Healthcare is another great example.
Yeah.
But it's tricky, right? Because healthcare data is incredibly sensitive.
Yeah, for sure.
Privacy regulations are strict and the stakes are very high.
Yeah, you don't want to mess around with people's health.
Exactly. But the potential benefits are enormous.
So how do we create AI that can actually be applied safely and effectively in healthcare?
Well, one approach is to train LLMs on a massive amount of medical literature.
Okay.
So research papers, clinical trial data, medical textbooks, so they can learn the language of medicine and understand complex medical concepts.
So we're giving the AI a medical degree.
Yeah, kinda.
That's pretty cool.
And we're already seeing AI models that can assist with medical diagnosis.
Oh, wow.
Personalized treatment plans and even help with drug discovery.
AI that can help diagnose diseases and discover drugs. That's amazing.
It's pretty incredible.
All right, let's talk about finance.
Okay, finance.
AI seems like it could really thrive there.
It could.
But it's also a very high-stakes environment.
It is. Financial markets are incredibly dynamic and complex.
Yeah.
Risk assessment is crucial, and decisions have to be made very quickly and accurately.
So yeah, it's a perfect playground for AI.
It is.
But you got to be really careful.
You have to be very careful
How you apply it.
Yes. So knowledge distillation is being used to create models that can analyze financial data, predict market trends, assess risk, and even automate some trading decisions.
So this is impacting like investors, financial institutions, really anyone who deals with money.
Absolutely. It affects everyone.
Okay.
Imagine having an AI financial advisor that can give you personalized investment recommendations.
I like the sound of that.
Or an AI risk analyst that can identify potential threats.
Yeah, that would be pretty handy. Okay, so we've covered law, healthcare, finance. Now I want to hear about how knowledge distillation is pushing the boundaries of scientific research.
That's where it gets really exciting. Because scientists are using knowledge distillation to train models that can analyze scientific data, generate hypotheses, design experiments, and even write research papers.
AI that can do science.
It's happening?
That's incredible.
That's pretty amazing.
Are there specific areas where this is having like a big impact?
Oh, yeah, absolutely. We're seeing it in fields like mathematics, astronomy, physics, chemistry, even geoscience.
Wow.
There are AI models being developed that can solve complex mathematical problems, predict the behavior of celestial objects, and even design new materials.
So AI is becoming like a partner in scientific discovery.
It really is, and it's accelerating the pace of research in so many fields.
That's amazing.
Yeah.
So we've covered a lot of ground in this deep dive.
We have.
From the fundamentals of knowledge distillation to its applications in these really specific industries.
Yeah, it's a fascinating field.
It is for sure. What are some key takeaways for our listeners, especially developers out there, who are like itching to apply these concepts to their own projects?
I think the biggest takeaway is that knowledge distillation is democratizing access to AI. It's making this cutting-edge technology more accessible, more adaptable, more affordable.
So you're saying it's like giving every developer a toolbox of AI superpowers.
Exactly. That's what I'm saying.
I like it.
It's opening up a whole new world of possibilities for building smarter, more efficient, and more human-centric applications.
That's what we like to hear.
Exactly.
So no matter what area of software development you're in, knowledge distillation is something you should definitely be paying attention to.
Absolutely. Stay tuned to this field because it's evolving rapidly.
It is. This has been an amazing deep dive. Thank you so much for sharing your expertise with us.
My pleasure.
And listeners, if you're feeling inspired to explore knowledge distillation further, be sure to check out the show notes for links to all the resources and projects we talked about today. And until next time, keep on learning, keep on coding, and keep on diving deep.